In today's lecture, I'm going to solve a problem related to epicyclic gear train. What is epicyclic gear train? It is a type of gear train where we will have two or more gears such that one gear will not only rotate about its own axis but also about the axis of rotation of another gear as well. Here we have three gears, gear A, B and C. If you see over here, this bigger gear is gear A, this gear is gear C and this gear is B. And this gear B is going to rotate not only around its own axis but around the axis of A or C as well. And we are given that the number of teeth on gear A is 72 and the number of teeth on gear C is 32 and the number of teeth on the B we will have to calculate it. And gear B is meshed with both the gears A and C and it is carried on an arm. Means that an arm is connected with the center of rotation of C and the B. The arm is rotating with 18 rpm. What we will have to do is to fix the gear A and then we will have to determine the speed of gear B and gear C. Over here we are given that this arm is rotating with 18 rpm. We will consider that it is rotating counterclockwise. It will rotate counterclockwise only if this gear C is going to rotate counterclockwise. As this A is fixed, so this B is going to rotate like this in clockwise direction. Because of that, it will move like this. So this arm will rotate in counterclockwise direction. If you add this distance, which is RC, with this dB, it is going to give you radius of gear A. So RA is equal to 2RB plus RC. Now if you multiply 2 on both sides, we will get to RA is equal to 2 into 2RB plus RC. So 2RA is equal to DA, and multiplying this 2 with this and this, it is going to give you 2 into 2RB. Since this 2RB is equal to dB, so we will get to dB, and 2C will give you dC. So dA is equal to 2 dB plus dC, and as you know that module m is equal to d divided by number of teeth. I will represent number of teeth with t and multiply t over here, so d will be equal to mt. So instead of this dA you will have to put mta, and instead of this dB you will have to put mtb, and instead of this dc you will put mtc. Take this m common from both and cancel it out with this m, so you will get ta is equal to 2tb plus tc. So rearrange this equation for the TB, you will get TA minus TC divided by 2. Since you know that TA is 72 and TC is 32, so putting these values, it will give you TB is equal to 20. As you know that the relative speed between this arm and this gear A is represented by an A EF, and it is equal to an A minus an EF. And similarly, the relative speed between gear C and this arm is represented by an CEF, and it is equal to NC minus NEF. And if you take the relative speed between arm and gear A to the relative speed between the gear C and arm, it is going to give you E. And this relative speed ratio is also equal to the ratio of their speeds, NA divided by NC, and this is equal to TC by TA. So is equal to TC by TA. We have written negative sign over here because in relative speed the direction of the motion is important. For example, if you take this point and two bodies start motion from here, one cover 2 distance and another cover 1 distance in the same direction, so the relative distance covered between the two will be equal to 1. And if you take the same two bodies such that one cover 2 distance in this direction and another one cover 1 distance in opposite direction, so the relative distance covered between the two will be equal to 3. So it shows that how much importance the direction has in relative motion. So that is why we have written this negative sign over here, because if you see C is rotating counterclockwise, because of that B is going to rotate in clockwise direction, and since the teeth on A is internally, so this A is going to rotate in clockwise direction if arm is fixed. So that is why we have written negative sign over here. And this B is idle gear. If you multiply TB and divide TB, it will have no effect. So putting the values of the number of teeth of each gear, it will give you E is equal to minus 0.44. So put this E equal to minus 0.44, and as you know that this is fixed, so you will have to put 0 rpm, and the rpm of the arm is 18, so put 18 over here, and rearrange this equation for the NC, it is going to give you NC is equal to 58.9 rpm. So gear C will rotate counterclockwise. Then after that, let's find out the speed of gear B. For that, you will have to take the ratio of relative speed between the C and arm and B and the arm. So this is relative speed between the C and arm, and this is relative speed between the gear B and arm, and the relative speed will be equal to NC minus NEF for the gear C and the arm, and the relative speed between the gear B and the arm will be equal to NB minus NEF. As I told you in this case, that it is going to be equal to TC by TA. If A is in the numerator, so for the teeth you will have to put A in the denominator. Similarly, we have the case over here as well. So it will be equal to the ratio of their teeth, but if there is C in the denominator, you will have to put the C in the denominator, and this B is in the denominator, so you will have to put it in the numerator, as the C is counterclockwise and B is clockwise. So that is why we have put minus sign over here. Now put the values of the teeth. It is going to give you minus 0.625, and as you have the value of NC and the speed of the arm, so put these values. It is going to give you NB is equal to minus 47.44. so we have found out the value of NC and NB. Now we can find it out by another method as well. And first of all, you will have to take a table. Over here you will have to put operation, and over here you will have to put revolutions of each element. And we have total 4 elements: arm, gear C, gear B and gear A. As you see over here, we have written it in a sequence. First of all, gear C will rotate, because of that gear B is going to rotate, and because of that gear A will rotate if this arm is taken to be fixed. So you will have to consider the sequence in which the motion will be transferred. First of all, you will have to consider that arm is fixed and gear C is rotating with 1 rpm, and then you will have to multiply that with x, and then you will have to add y with that, and after that you will get total motion of each element. So first of all, if you consider arm to be fixed, so its speed will be equal to 0, and as it is assumed that gear C is rotating with 1, so it will be taken as 1, and as gear B and C are meshed with each other, as you know that the ratio of the gear speed will be equal to this, NB by NC is equal to TC by TB, and you will have to put negative sign over here as well, because they both have opposite motion. And as NC is 1, so put 1 over here, you will get NB is equal to minus TC by TB. Similarly, if you take NA by NC, it is going to give you the ratio of their teeth to, since NC is 1, so you will have to put 1 over here, and you will have to put minus sign as well, because their motion is opposite to each other. So NA will be equal to minus TC by TA. Now what you will have to do is to multiply these with x, you will get this equation, and after that to each element you will have to add plus y. So you will get for the arm plus y, and for the gear C you will get x plus y, and for the gear B you will get y minus x into TC by TB, and for the gear A you will get y minus x TC by TA. These are the speeds of their respective element. So the speed of arm is plus y, as you know that arm is rotating with 18 rpm, so plus y will be equal to 18. This is some of the calculation and given data from the previous method that we solved. And as you know that the speed of gear A is equal to 0, so you will have to put 0 over here, and you know the value of this y, which is 18, and TC is 32, and this is 72. So putting these values and rearrange it for the x, it is going to give you x to be equal to 40.5 rpm. So put 40.5 over here and 18 over here, it is going to give you 58.5. It is speed of the gear C. And similarly, the speed of gear B is equal to this one, so put the value of y, that is 18 rpm, and the value of x, that is 40.5 over here, and the value of C is 32, and the value of B is 20. So when you put these values, it is going to give you minus 46.8 rpm. So this is another method to find out the speed of gear B and C.